Hello everyone. Recently I have posted this post about the UI layouts in pure script, and I'll try to describe what does it mean and I will try to do it visually, and these videos should serve as the companion for the post. That's my intention, at least. So the first thing is that I have watched this awesome video of how Clay UI algorithm works. You may find the link in my post. And I think for many developers it was shown just right away in the YouTube. I will not open it right now, not to mess with my recording. So actually this is the library pure script to build user interface layouts to help developers define them in an easy way. Sometimes we do it with the constructors, maybe not like mine, but rather something like from Xcode, where we have constraints and the different panels, they can spread in different directions and it's all configurable. Mine is more modest way to do it because it's just the helper interface we developed together with Cloud AI. To help you visually see what happens in different cases. And I started this project just because I have several other projects in development and I need the user interface for it's rather complex interface, I would say. I hope you think so as well. And so I need it to be responsible, responsive and responsible as well. For example, in this case, if I switch the panels on and off, they're aligned here, and if I resize the window, which I will not do now, the UI will follow. But it's not the only case. I also have these nodes here. I have the keyboard interface for them. And the thing is, these nodes are as well, they have layouts. They can have many inputs, one output, or vice versa, and they also can have some body here inside. It should have been here, but somehow it's not. So yeah, this is the one option of the interface. There could be a lot of nodes. They also need to take some space. Actually, this layout is also it has several layers because you can switch off the user interface for example, or you can replace it with just the color, the solid color, if it would help you to use it easier, I think. So yes, and another example is this tree navigator. I use it for my own data storages to navigate them easier. It also has keyboard navigation and just different panels. You can go inside the part of the tree. You can go on top. Also, you can pin some nodes. If you want. And there is also selection. Here actually there could be something else could be rendered. It's also the history of where did I go. All these are also navigable. And there is also zoom. And that stuff. Yeah, that explains the examples I have here, because now both these projects, not only these, but these are good examples, they use this play layout system and this nodal UI, for example, you've seen here. It is, you can also have patches here and add different patches, for example. It all was developed here, sometimes post factum. First I developed the interface and then used this layouting for else. Yeah, also there are status bar buttons here. So yeah, this is also responsive, and usually I show how responsive it is. If I just change the size or just manually 600, for example, it's just the root component I have to change, and in my code this 1 pixel fits perfect. If the window size changes, I just resize the parent container, and everything else is described relatively. Mostly, for example, this patches bar, it says it grows on the width and grows as well on the height, but it's probably because it has a parent which has a fixed height of 30 pixels, and this one grows as well, so to keep this height constant. So as you may see, you may navigate freely through the interface here and change the values. For example, I could say that I want this panel to have the fixed height, and as you've noticed, everything else resized because I think every other panel here has the grow for its height. Yeah, right. And also you may navigate this way. These are the buttons for the previous child and the next child. This is the parent, where we can see the children. Yeah, just like this. There is also another panel which appears maybe not in the best place of the interface, but it could be useful. It shows the structure. As you may notice, here it's actually not that huge. These are all side panels buttons, those green here, and you also have the description here, just a short one, encoded. Like, for example, this arrow means that they go from top to bottom, and things, I know it's very little, it means they go from left to right, and there is also top back to front, which is just layering, and it even didn't break so much than I expected. And usually it's just you switch the things back as they were and it works again, because the algorithm is the same. So this is the interface for this 3 renderer. It's also defined here. Fold is what I named this panel. It shows what is selected now, just the whole tree. If it's a large one, it just scroll, but it auto scrolls to the places. And this one is also gonna go to the root and also try to change the size. The constructor is also responsive, so as you may have noticed, yeah, you can also expand and collapse it. There is also this checkbox which also shows the encoded sizing. It helps me sometimes because, yeah, you see it's left to right, growing by width, and fixed height, which is 40 pixels and now more. This one fixed by width, and the height is growing, and so on. Mostly this one is growing, this one has fixed height, this both growing, and so on. But this one is the simple UI. Yeah. With the nodes from Noodle, it's a bit more complicated, because I will check if I have, I have this girl in the middle element here. It is because there could be body of this node, and if its width is for example less than the inlets we have, we still have to expand this part to feed the inlets and outlets, and vice versa. If the body is takes more space than inlets and outlets, we have to expand these areas. And that's why I had this growing experiment here. Let's change it to 40, for example. This one to 40, so it would look like the original node. We have buttons here. We have the body content here. And now, for example, if inlets are getting less in size, this grow middle compensates. Or for example, if we have truly a lot of inlets, it also grows this way. And on the other hand, we could also have just one inlet, for example, and one outlet. It didn't work as expected because probably the height is fixed and the width is fixed. Okay. So yeah, not every time it works as expected. I will add the test for it. Maybe it's because of this wrapper, because it should fit mean. For example, what if I say it should be 200, or maybe this is body weight. Yeah, this one has to be. So yeah, sometimes it goes to the experiment. So yeah, maybe body content should be just no less than something. Yeah, so like that. And if we reduce some of these values, so yeah, in the tree you can also select any of the elements. Here nothing happens. Here nothing happens. Oh yeah, but it's because here I will. Yeah. What I wanted to show is that it grows bigger and bigger when you extend the body content. To this 1000, for example. Yep. Also, I have the examples from the original video here. For example, we can say that this yellow element grows by its height. When it's fixed, it's just like that. Also, we can go to the parent and say, for example, that all the children are aligned to the bottom. And change different alignments here. And if it's different from default value, is also represented in the encoded thing. It's not visible on the blue square because it's behind this one. We can say 0, and then we will, yes, still will see the label from the pink one. The very hard example, the complicated one, is this mahjong table, because there are different directions. The children elements, they are rotated to the side where the player to the wind. These tiles, they can also be flipped, because if you take the tile from another player, you have to flip it, as I recall, and so on. So this structure is kind of complicated because we have the root is actually layered. So there are 5 layers, and the first layer has the tiles of different winds. Every layer has the tiles of the winds, and then here we also have these cards, which are these tiles in the center, and they are in their own layer. And also there is the inner table, which is this course area, which is in the center, and it also has different alignment and padding and stuff. So yeah, it's, if you want, it's for you to explore how it's done. Actually, this very example, it helped me to find the issues, several issues with percentage and everything in the algorithm and the alignment, and we fixed that. It's all covered with tests. I will show it in another video related to the code. Actually, regarding the code, this one is not highlighted, but it is pretty safe to take this code and paste it in your actual pure script code. It's just that these values are strings here, and you can replace it with the actual data type values or anything you want. It was worth noticing that we're looking now at the code for the particular part of the mahjong table. It's not all of the code, so we can go to the parent and then to the parent and then to the parent, or just to the root right away, and you will see that there's truly a lot. Those are rounding problems. It resets the selection, this button. As well, those are similar, these buttons and these buttons, so you can navigate through next child, previous child, if the parent has some. There's also exporting to JSON, which the JSON definition can also be loaded. and when it's big, but it also shows you the JSON only for the particular part. And the YAML code as well, it just has these string encoded lines describing how the section is aligned and works, and this code I can parse and restore as the layout definition from it, and that's what I did in the tests. Not to define everything with the code, I just use these short string definitions. There are also kanji examples. They also show you how one can align the different parts of kanji. Those are all of those examples. They have the complete kanji, because without it it looks worse, and the parts that with which parts it was constructed, and so for example the middle part, if we change the percentage, it grows. Let me show you another one. Yeah, this one is complex. So yeah, as well, we enlarge one part and other parts become smaller if they're not fixed size. And we have the menu example from the original video here. It's the height with the menus. Of course, it's not manually generated, and every item is just a function which takes its name, and that's it from the array. So I think this is it. Oh yeah, you have this blank UI for the experimenting. Yes, child 1, child 2, child 3, and you can write red here, or I think you can use hex. Yep. And aqua. There is the burly wood color, for example. And let's say that it grows here. Let's say we align the children in the center. There, they feed the center. So in the middle, at the bottom. So let's keep this center alignment and make it fixed. So yeah, it's aligned. And every cell can have its own children. And it goes deeper and deeper. So child 1, child 2. So like that. And if we change the direction here from back to front, yeah, we mostly see the child 2 and child 3 is aligned in the center. So yeah, it kind of breaks. But worth experimenting. This actually, this should be expected. So yeah, thank you for your attention. Hope you will find my library useful, or at least the experiment. Thank you. Bye. Have a nice anything.